Okay, so first,
I need a new one.
do you? Is yours got the rip on the back?
Mine-
I didn't-
No,
mine
I
has
said
a
I
rip.
needed a new one because I had an old one.
Oh, okay. So you guys should all have one of these on your desk. This is my gift to you.
Thank you.
You're welcome. So these are just creek birds of California. You should recognize a bunch of them if you go through it real briefly. Don't focus on them right now. We'll talk about them in just a second. I just wanted it to be quick so I could pass them out to you. So that's what these are for. We're going to talk about just a couple things in these sorts of books in a second. The other thing, sorry Emma that this is taking up your desk.
No, it's cool.
So these are some very, very old specimens that may or may not be older than your teacher. I really don't know. They were here when I was in school. We need to invest in some new ones, but they still will work for this purpose. So after I show you a video of one of your faves, the Untamed Science, we'll get there in a second, I will let you guys come up and check these out. They are so old that not all of them have their label. So you're just gonna have to, if you have a question, like come and ask. But I want you guys to take a second, look at the labels, and check out like the orders and basically just the classifications on these labels, the ones that do have labels. And I have set a few that are in the same order, and I want you guys to take a look and be like, okay, these are in the same order, but they look very different. Look for the similarities. Just kind of mess around with like looking at classification stuff. So that's what we're going to be talking about today is just classification, and then this will give you kind of a hands-on opportunity to like look at some actual preserved specimens, and like these are all mollusca, but you've got squid, and there might be a snail in here somewhere.
Snail?
There's even a hermit crab in here. Some of them are dried up and very yucky. Don't shake them, they're fragile. But we'll get there in a second. So, I gotta turn my TV on first.
I have a question.
Yes, Adrian, what's your
What would
question?
happen if you opened it? Would they escape?
No.
Would they speak?
Okay, yeah, hold on, what's up, Jade?
Big fins.
Are they immortal?
No, okay, you guys, so
Are they?
they're all dead. These are all dead.
Damn.
And I would assume, you guys, that these are so old, there's a chance that they are still preserved in formaldehyde, which is very toxic. So please do not open these. It's very important that you don't open the specimens, because it's just no bueno. Okay, so don't even be tempted to do that.
But they're
Just
so
have like
delicious.
children, they're gonna escape.
We should get live specimens.
Gross. No, we're not gonna think about eating them. They're not delicious.
But it's fun
That squid is
size.
bite-sized though. Did you see that?
Ew.
Perfectly sized.
Think about how crunchy it'd be.
God,
Actually, it'd be more like a wet noodle.
Ew.
Seeing how old it is.
Ow.
Okay. Untamed Science, 8 minutes on classification. They're talking about like a potentially new species of fish. They didn't really find a new species, but you just gotta work with them. Buddy, yes, is it a valid question?
Yeah, you should totally rotate the TV slightly.
Oh, if you want, just scoot over.
Oh. Too much effort.
Make sure you can see the screen, please. Angel, can you see it okay? I'm gonna turn the lights down, so. Thanks. What's it look like?
There it is. The largest animal in this area, the brown bear.
Here it's called a grizzly,
Russian grizzly.
or Kodiak. A silver-tip bear, and it has its Latin name, Ursus arctos horribilis.
What's in the name? As much as bears that have this controversy over the name.
Oh my gosh, I'm sorry.
Common names for the same organism? How do scientists refer to an organism to get around this name mess?
Because I do annotations on it, but I think that's what he looks like. So
Today we're looking for a fish species that we've never seen before. Every Every dive becomes almost a new adventure that way.
That's right. We shoot as much video as we can of every species we come across to anywhere in the world. We then compile them into online identification guides through untamedScience.com, and it's this video we use to help us identify new species. Let's go. Underwater, we see an array of beautiful corals and colorful fish. Every one of these animals has a unique classification, grouped by their similarity to each other. For instance, there are many species of fish that we call butterfly fish. Most look fairly similar with yellow, black, and white coloration. They have somewhat similar behaviors too. For example, you always find them swimming over the reef in pairs. They mate for life. But while we're able to identify most fish, some fish we're just not used to seeing. And that's exactly what we found today. See it in there?
That looks cool.
Like an eel.
Thing's gonna tip it over. What is it? Most of the time you can identify organisms using field guides. But not always. What if this was the first time this fish had ever been recorded?
Well, then we'd need to name it. Today we call the practice of naming and classifying organisms systematics. But giving names to plants and animals started a long time ago with a guy named Linnaeus. In the 1700s, this Swedish doctor decided he'd give plants and animals names and then group the species together based on their similarity to each other. But he didn't just name things randomly. There were rules to keep things organized. He decided that every species should have a two-part name. The first part would be the genus, kind of like your last name, and the second part, the specific epithet, which is kind of like your first name. For example, the scientific name of humans is Homo sapiens. Latin is the language of systematics, so every name has to be Latinized. Today, this system is a nested hierarchy of classification into which all organisms fit. As an example, let's use mammals. All mammals are grouped together in the class Mammalian. They're then divided up into increasingly smaller groups called orders, families, genera, and then species.
This all seems easy to understand, but who really decides how an organism's day is named and how do they do it? Let's take an unknown fish and go see an expert. So to help us answer some of these questions, we're at the Bishop Museum. Dr. Richard Pyle.
Well, my name is Richard Pyle. My PhD is in the study of taxonomy or systematics, which is the study of what organisms are out there and how they're related to each other. We operate very much the way a library does, in the sense that people come here, researchers will come here and examine our specimens just like people go to libraries. And so we have all of these specimens. We've got about 40,000 of these jars in here, and they range in size from little guys like this and stuff that's even much smaller than this to very big things. We have shark jaws, we have large specimens, we've got sharks, we've got all kinds of things. After we collect the specimens and examine them, we search our literature, we search our books, we try to find out whether or not it's a known species. And quite often in the realm where we're working, if we don't recognize it, it's probably a new species, which means nobody's ever seen it before. Well, this bank of shells right here is far and away the most valuable part of our entire collection. And the reason for that is these are all of our type specimens. So you see a lot of these have little red ribbons on them.
Type specimen, that's it.
Holotype, right. The red ribbons are the holotypes. So those are the name-bearing specimens. So this holotype is, as I said, the specimen that bears the name. And we collect it, we examine it very carefully, count up all of its spines, all of its scales, certain measurements, we get proportions, we describe its color, we take photographs, we take x-rays, we do all these things to sort of get a sense for what this species is. So write it up in a scientific paper, and then we publish it. And once it's published, that's when the new name becomes available for people to use.
So now we know how scientists use species and names. Let's see if we can give ours a name too.
garden eel right there. There's 2 of them in that jar.
That's the ones.
These are the ones, yeah.
The reason they're called garden eels is when you're out on the sand on the bottom of the ocean, you see them. They look like a garden of little, just long, thin branches sticking up. And then if you approach them as a diver, they disappear down into the sand and vanish. The group of species isn't completely well known. There's a number of named species, but there's also a number of species that haven't yet been named. So they're still being discovered in this group.
But remember, there's lots of new species to be discovered and filmed. And now you know a little bit about how to name animals. You get around all the confusion of common names. Now you use the official scientific name.
Yeah, in fact, you may have already seen a new species without realizing that it's new to science.
And remember, if you want to find a new species, well, maybe you can. And the best part is that when you find a new species, you get to name it. Only meaning.
Robicus fishiae.
So never stop exploring the old world.
Thank you. That's kind of cool, huh? So they're using all those jarred species like ours, like a literal library, but instead of books, it's dead animals in jars. So I should have brought you guys some of my skulls. Maybe I will do that this week. I have a lot of really cool skulls too, because I do art with them. Yes, I know. I don't. To get a replica of a mountain lion is like a couple $100. But okay, you guys. So why don't you go ahead and come up here? I'll spread these kind of out. Go ahead and get up close and personal with them. If you guys go to college and you're in the natural sciences, you're gonna see things in jars like this. So just, it's a little creepy, but get used to it now. It's really cool. So come on up. Is that a These guys have beaks, so it's gonna be in the center of all their tentacles. Yeah. So this one's very yucky, right? It's kind of old and falling apart. But these guys are both an Echinodermatata. And look how different they are. This one, you guys recognize that at all? A sea urchin.
Gross.
And this one's a starfish. But they both are classified similarly. Here, hold them. Yeah, true. Yes.
What is your nail?
At one point it might have been pegged to something. I'm not sure. But maybe someone dropped a nail.
Oil,
in there.
I wonder what formaldehyde is like.
You guys had hydrozoa, right?
Oh.
Here's a little specimen for your jelly.
It's in the jelly.
Oh.
In the jelly.
Angel so far.
Ew, that's a tapeworm. Yeah.
Thank you.
This one's a horseshoe crab.
Wow,
this
there's
is actually
literally
kind of
nothing
cool.
in there.
Is this evolution?
It's not.
It's also quite decrepit. What would you say?
Evolution peak.
Evolution's peak? No. Related to trilobites and stuff though, so maybe.
Oh no.
Very fragile, very small specimen.
Is that a turtle?
No, it's a
This is a
horseshoe
turtle.
crab.
I know.
This is a turtle.
And these guys have blue blood. Very cool.
Gross.
Yes, there's a turtle right there.
They think
I saw
they
it.
can be different.
There's a
Hey, look,
very
it's a
dead
turtle. Nah, he's alive.
Is it alive?
Yep, it's alive.
What order are turtles in?
He's fine.
No.
He's taking a nap right now. Yeah.
What is a turtle, you guys? It's a reptile, so it's probably in what order? Yeah, good. Reptilia, not reptilius. Sea anemone?
Can I take a picture?
Yeah, you guys can take pictures. That's fine.
Lobster. It's not a lobster, is it?
What is this?
That looks like a
Liver fluke.
big old prawn.
That's why I said it was.
It's a liver
Parasitic.
Oh.
What is it?
What?
Oh, roundworm.
This is a sand. Stop trying to drink potions out mouth.
No, it lives inside your intestine and just
You
takes
guys
all
pay
the
attention
nutrients
though to the
you get from
labels.
food.
Check the labels.
That's how people can starve on a full stomach.
Why is the label in
Lobster.
Chiroptera are bats. Some of them are dry specimens.
This is my favorite specimen.
You should look
Hey,
at
buddy.
This is a jar of dirt.
I've got a big jar.
I think I.
Yeah, you guys, this doesn't have Chiroptera on it, but there's a bat.
I got the bird's eye.
Mammals. That one's so old, it looks as though it has disintegrated.
deteriorated.
Just
Yeah.
literally.
Ah,
It's literally just.
it's broken.
We'll get to
It's
that.
broken because. Yeah, go ahead.
If I can find the other.
I thought that was my dad. I thought that was my dad for a second.
A little baby starfish. Glass.
They do.
It looks like those statues from Metroid.
If he doesn't like the crayfish, maybe
What is it?
It's a sardine.
Oh my god. Ew, you can see the sheen.
Most bugs have chitin.
Wait, what is that?
Actually, I'm pretty sure what the fingernails are made of.
Keratin.
Keratin, yeah.
Oh, I always thought it was chitin.
No, we're talking about the
I've read-
exoskeletons of
Ooh,
insects.
sea urchin.
Jar of darts.
What's chitin?
Keratin.
Chitin's made.
Chitin's
It's
the
like
exoskeleton.
exoskeleton. Good
Yeah.
job.
Oh, well, it's keratin.
Keratin is the stuff that are. It's,
Oh, it's separate. I see what you're saying. Okay,
Yeah.
gotcha.
I always mix them up because they sound the same.
Classification.
They sound similar, so I always mix them up.
All right, guys. Go sit. Go sit.
I'm fired.
This jar.
Oh my god, you poor bastard.
This jar has a jar in it.
Put it in there.
This jar has a jar in it. It's just your.
Yeah, the snail.
Jar
Excuse me?
in the box. Jar in the box.
There's a pregnant jar.
No, it's a classification of how scientists classify things. Gotta keep the jar in the jar.
You guys, I don't mind. This is cool. I said the jars in the box. Thank you. Yes.
I feel bad. I feel worried.
For what?
Because I feel like I'm gonna break one of these.
So do I.
No, that would be terrible because it would get all over.
Yes, it would. That's exactly what I'm terrified
Okay.
of.
Joe, you should take a
Alright,
sip.
this is all you
All
guys.
right, let's go
I'll go back to
now. Yeah, Buddy, Emma, go ahead, put those back in the box. So, Buddy, no, we don't talk like that.
You're such a great one.
Yes, thank you. Okay, Hadrian, you guys bring it back in. What did you guys notice about the jars, besides the fact that it's kind of cool, kind of gross? Yes,
They're
Emma?
all like yellowish, oranges inside, like the window.
Yeah, I think that's just from it being old. Arizona, what did you notice?
There's dead animals inside.
That there is, dead animals. Deja, what did you notice? Yeah, what about the animals though? Did you notice anything specific about certain? Nope, Deja's turn. Some of them are dry, yeah. Hadrian,
At this time, it is unconfirmed if they are alive or not.
they are dead. Okay, Jade.
Are the ones that like are aquatic in the juice?
Yeah, you could say like the ones that have like really soft tissue, definitely gonna be. And the formaldehyde, the bat, not so much. I don't know why they let that one kind of mummify, but no, you guys, what'd you notice? Like, Emma, what'd you notice about the labels? Some of the labels.
They have like their common name and then their like the species, the group, and then like the general like, name.
Good. We
Have
call
like all the information.
yeah, and we call that different levels. Buddy, no, different levels of what? Quentin, go. Come on, you're ready. Marilyn. Walnut species is one of them. Close. Go, Emma. Different levels of.
Systematics.
Good. Yes, systematics is part of this.
The variation.
Classification. Classification. Yes, classification or different levels of taxon. You guys, taxa. Okay. Bring it in. Bring it in. Okay, actually, let's flip these open real quick. Miss Young's had a couple cups of coffee today, so I'm feeling a little hyper and sporadic. So bear with me.
No wonder I'm scared.
Okay, open this to really any bird. Any bird.
Hey, look, I found one.
Any bird.
This page has a bird on it.
I have my favorite one. I think.
No way.
Great.
Isn't
Okay.
that nice?
Hadrian, what do you notice?
Uh,
What bird do you have? What's
I
it?
have the kingfisher.
Kingfisher. I love that one. Okay, great. What is its scientific name?
Hang on, I lost it.
Uh-oh. Just find a new bird. Any bird.
No, I have to have the kingfisher. What's that?
It's very selective.
Just go for it. Just full send it.
Cheryl.
What?
Cheryl,
It's scientific.
It's okay.
Transformer.
What?
Alcyon.
Let me see it.
Pretty sure he's just guessing.
Let me see it. No.
Cheryl Transformer.
Cereal Alcyon?
Yeah, that's pretty close.
Okay, guys, so
Is
no.
that
I
Cheryl?
did that on purpose, you guys. We're gonna have a little fun
Where
with
are you
this.
going?
You guys, it's Latin. It sounds like gibberish. You're gonna stutter on these scientific names, and you're gonna sound stupid, and it's okay. Everyone does when they first start. When in doubt, when you're in college, you're trying to figure this stuff out. Just Google it and ask how do I pronounce this on YouTube. That's what I did. I'm not even kidding, because the worst thing is when you're in class and your professor's like, okay, Brandy, what's this specimen? And you're like, Empedodonyx chalilia. Like, it's okay. Everyone does it. It's fine. But this is just crate birds, right?
Yeah.
Normally, if you have like an Audubon book, it's going to classify like hawks, owls, wrens, sparrows, things like that. They're all going to be sectioned up. And within each one of those sections, there's going to be a bunch of birds like this. So these authors classified this just as crate birds. And you're going to see everything from ducks to hummingbirds. Buddy, what are you doing?
I'm showing him this really cool bird.
Tell us about your bird.
Oh, well, I don't know how to say it.
Go for it. Just go.
Parnapalepa.
No. Try harder.
Fane
Mm-hmm.
O Pepla.
Okay, what's the second part?
Mittens.
Okay,
His name's
you try.
John.
Let me see it. Yeah, I don't know. Good enough.
Yeah, that's what I thought.
Why don't you just know how to pronounce it?
So you guys, you see, I did this for a while. I still sound ridiculous when I try some of them, but it's okay. So what else does this like tell you? What else is on here? Go Emma.
Their diet and their habitat.
Yeah, good. Arizona. Anything else?
Range.
Yeah, good. Maryland.
Their identification.
Yes.
Habitat improvement tips.
Oh, lovely. Yes, isn't that a great one?
Their identification.
Okay, so this gives a little information on each one. And what is this? What is this for, you guys? What is this for?
People who want to go out and
Yeah,
identify.
good. Yes, it's for identification. So it's a tool, right? A tool just for identification. Not necessarily classification and not naming, right? It's just a tool for identification. So,
My bird's
scooch by you real quick.
Oh,
Okay, so first thing that we've touched on, Emma. Okay, we have identification. You're just trying to figure out what species. You want the specific species. You're looking at a bird or you're looking at a plant. You don't know what the heck it is. You use this, it helps you identify it. That's one tool. A field guide. And bird nerds, you know, now you have your very first field guide.Maybe your first. I don't know if you guys have others, but there's field guides for everything. Mammals, tracks, everything.
Yeah, why do we use spider for
Kind of
everything?
cool. So CETA.
CETA?
That's in left moving too.
CETA.
Okay. Okay, you guys, what is this animal? No. Shh.
Okay.
Emma. No. Mountain lion. Arizona, what is it? No, different word than mountain lion. No. Still keep specific. You know,
It's in the kingdom animal.
No.
A cougar.
Good. Cougar. Hadrian, give me another one. We have mountain lion, we have cougar.
Okay.
What else are these called?
No,
you guys
stray
stop.
cat.
No.
That's very muscular.
There's one
And
more that
also
starts with a P.
Not a stray cat.
Panther.
No.
Puma.
Puma. You guys, puma.
What a
This
weird.
one animal, you guys, for common names that Adrian missed, I don't know how. Puma is a scientific name. Puma concolor. Okay? But mountain lion, cougar, puma, 3 common names for one species. That can get very confusing. So it's one more reason why scientific names are important. Okay.
Okay, Joe. D&D.
So,
You guys, why are we talking? Why are we doing that? Stop. Okay. Alright, anyone that has to take plant taxonomy in college, I wish you luck. That was the hardest class I ever had to take. This is but a taste of what you will be doing. This is a dichotomous key. We have a field guide, just straight up like this is what the bird looks like, this is what it sounds like, its range, blah, blah, blah. Great. But what happens if you find a leaf in the wild and you're like, what tree does this leaf belong to? And then maybe you have what's called the Jepson, and it is this thick, massive book full of nothing but this little page here. It's a great tool, and I'm gonna have you guys, first, does anyone want to volunteer to work through this? Anyone want to take a jab at it? Hadrian, you're gonna do it. Hadrian's gonna do it. Hadrian's gonna do it. Okay.
Lucky him.
Hadrian, why don't you come up here? So you can see this a little better. Okay, so this is the way it works, you guys. There's gonna be dual sentences, okay? Basically, it's always gonna be like, it has this, or it does not have this. When you find what it does have, it'll say, go to step whatever. So Hadrian's gonna start at step 1, A. And he's gonna look at this leaf. So go ahead and read that, Hadrian.
Compound leaf, leaf divided into leaflets.
Okay, great. Now read 1B.
Simple leaf, leaf not divided into leaflets.
Okay, we have our first thing that we need to look for and see if it does or does not have it. So look at your leaf. Is it divided into leaflets, or is it but a single leaf?
Looks like a leaf to me.
Just one?
Yeah.
One. Great. So look at the very last column. What's it tell you to do?
It says to go to step 4.
Okay, so we're going to go to step 4. Go ahead and read 4A.
Veins branched out from one central vein.
And 4B?
Veins branched off main vein in the middle of the leaf.
Great. So look at your leaf. And what does it have?
Looks like it's branched off the middle.
From the middle, he says. Great. So what's it tell you to do now?
Go to step 6.
Now we're at 6. We're looking at the edges. 6A. What does it say?
Leaf with jagged edges and leaf with smooth edges.
And what do we have?
Jagged edges.
And so what is it?
It is possibly a birch leaf.
Likely a birch. Good job, Hadrian. Everyone give him a round of applause.
Wow. That
Okay,
sounds like terrible.
so you guys, that is how a dichotomous key works. It's kind of fun. It's almost like a game. You're trying to travel through what it has, what it doesn't have, and you're trying to get to one end point, which is the species. Of course, birch is not super specific, but you guys understand how that works, right?
You said there's like a big book of just that.
Yes, and it is brutal.
So it's like step 1, if it is whatever, go to step 5,000.
That sounds horrible.
Not 5,000, but like sometimes, depending on the complexity of like the thing that you have, it can go to like step 20. And I'm telling you, like, you will be sweating. Yes.
So does like the big book have all the plants of the
Yeah,
world?
it's not all the plants in
Okay.
the world, but like many. And I think the
Jesus.
Jepson might just be California. It's been a long time.
Oh, okay.
But it's a ton of plants. And in your plant tax class, sometimes they'll just give you a leaf, which is normally pretty easy. But if they give you a flower, you're looking at the number of like sepals, the number of stamen, and you're under like a dissection scope, cutting it to see how many of like this or that it has, and it gets very complicated. So just know this is basically the most simple version of that ever. But if you can understand this, technically you can understand even the most complex of dichotomous keys to a point. It all works the same. It's just a matter of how well versed you are in identifying the number of things and the jaggedness of the leaf shape and all these different things. But that's how a dichotomous key works. It is another tool just for identification, not classification and not naming. Okay.
Oh boy.
All right. Folks. Sorry. Okay. We're familiar with polar bear, right?
Yeah.
Go ahead and say that, Emma.
Say it.
Don't panic. It's okay.
Ursus maritimus.
Very close. Ursus maritimus. Okay. So genus and species. What's our genus do? Mercedes. What does our genus tell us? So we've got 2 parts, right? Ursus maritimus, genus and species. Which one? Start with this. Which one's more specific? species is more specific, right? Because remember, if it was like our names, this is our last name, this is our first name. Lots of people in your family have your last name, right? You're all in a group. But only, well, usually, like me, I'm the only one in my family that has my first name. And that's how you know you're talking about me. So this is specific, this is more general, right? So what does this tell us? What does your last name tell anyone else about you? Your genus, yeah, but it's a what? It's not a single individual, it's a group. This is a group. Our genus tells us this belongs to the group of true bears, right? So this has, I think, 5 other bears in it, including our grizzly and our black bear, other ones that I'm not as familiar with, okay? And then our species, Meridimus. We've been talking about Latin names, how weird they sound, yada yada. But has anyone wondered, like, what's the point? Why use this species? Yes, Arizona.
Isn't it maritime,
So close. You're so close.
Yeah, it's similar, yes.
Yes.
But it has to do with it.
It's like, it's like a weather,
And what is it kind of oriented around?
What does maritime law deal with?
Yeah.
Yeah.
But what does
You're
it deal
so
with?
close. Yeah, what does it deal with? You want to phone a friend?
No.
You should phone
No,
me.
she wants to figure this out. Let her work through it.
No.
No, you don't? You want to pass it off? Me? Adrian,
Yeah,
go
it's
ahead.
right here. The sea or
Yes.
the ocean.
Yes, the sea.
Yeah. Maritime law has to do with like
So
boating and
think
things like that.
like marine. This root here has to do with the sea.
Well, yeah, that's
Yep.
where we get the word marine from, and maritime is derived from marine.
Yep. So Meridimus just has to do with the sea. So we know that this is a bear. This is a bear that in some context has to do with the sea. Sea bear. Sea bear.
That's what I.
So you guys see how that works though? Like obviously no one knows Latin like the back of their hand, right?
No one cares about Latin.
But at some point, Adrian, buddy, focus. You can probably kind of guess that this maybe has to do with the sea. If you know like marine or maritime. What was it? I just struggled. Yeah, good. Okay, great. So there's a point to that species name. Like with our, does anyone know what this is?
That's a tree.
No. It is a tree, but like the species.
Okay. I think you were right.
Maple. Good. And but we have a, sorry, I just showed you guys because I forgot for a second. So you guys, Acer is the genus for all maples. You see how red this guy is? Bam. Rubrum. Has to do with red. So it's a red maple. Boom. See these scientific names, they look scary, they sound scary, but they're actually very simple.
I guarantee you that's close to the word for red in Italian too.
Yeah,
Rubrum.
totally. So it's
I know
That's
how
what
to
I get, like,
happy
shook up about.
birthday and my feelings
Okay.
out.
So you guys remember Buddy, Villa.
What?
What are you literally doing?
Sorry, I might have said Buddy when I meant Hadrian.
Just for that, I'm
Focus.
thinking of math.
Okay. In the video, no, you're gonna wake up right now. In the video, we heard the name Linnaeus, right?
Yes.
Yes, someone remembers Linnaeus. Is anyone familiar with Linnaeus? He's not as well known as Darwin per se, but he preceded Darwin.
Guy from that show.
He published his work on systematics a century before Darwin published his findings on evolutionary theory and everything, ancestry and whatnot. Isn't that crazy? So think of it like this. So we've got our homeboy Linnaeus. That's my homeboy. Way back when. And this is before, keep in mind this is before Darwin published his stuff on evolutionary ancestry. So when he's categorizing animals, he's not looking at the evolutionary ties between them at all. What is he looking at directly? What would you look at if you were Linnaeus way back then and you're looking at the animals and the plants outside?
Physical properties.
Good, Philip. Yeah, so physical properties, literally what you see. And okay, Marilyn, you're looking at the physical properties of two animals. What is your mind doing between those two? What is it looking for?
It's finding similarities.
Yes, good, and? What's the opposite of similarities?
Differences.
Yes, good. Similarities and differences, that's what Linnaeus is looking for. That's all they're looking for. This is our traditional, old-time, classic way of categorizing, classifying things. So, believe it or not, some of his orders, not just orders, but some of his classifications still hold true today. Even though, now we take into account evolutionary ancestry when we classify things. Isn't that crazy? Like, way back then, he's still on target. He's a very good scientist. He's very particular about his classifications. That's why it took him so long to publish his own findings. Okay, and this is the guy that figured out that there needs to be binomial nomenclature. I'm gonna get by you again. Sorry. Okay. So we have our identification. We already know that's one thing. We're just looking to figure out what the heck the species is. Now we have binomial nomenclature. What does this word mean again, you guys? Just this word?
Name.
Say it louder for the people in the back, Philip.
Name.
Like naming things, yes. What does binomial mean? Two. So two names, great. Two naming.
And they should have just called it that.
Am I-
The two naming method.
Yeah, well, we can't call anything that simple, so.
The scientists,
True. Always wanted the Latin.
What's wrong with this? If I write it like that, what did I do wrong?
Wrong order.
It's backwards.
Go Arizona.
You didn't underline them.
Good.
Individually.
What's wrong with this?
You need to do it individually.
Good. What if I had lowercase this?
No.
Oh, it's terrible.
wrong because
What the heck?
What?
You like
What
this
if I get
video?
this?
the scientists hate you.
It's just a list.
What is my professor gonna do?
Kick
Just
you
say
out of
it.
class.
Oh my god, isn't that all wrong? Isn't that disgusting? Oh,
Wait, capitalize the P for the second part.
he's gonna throw me out of the classroom. Okay,
He's gonna get a giant sledgehammer. Just
so you guys, stop that. Is anyone in here like confused with scientific names at all? How you properly write them?
Somehow
Go, Joe.
Are both of them capitalized?
No.
Okay, gotcha.
So correct.
Just
me.
the first one.
Was actually the
I'm just
first
double
way.
checking because I was confused.
It's okay. That's totally fine, you guys. Right now, you guys know me.
Classic Joe.
I always say, like, there is such a thing as stupid questions when you ask something that's off topic and totally random and just wasting everyone's time. But if it's on topic and, like, you're not sure about the naming part, go ahead and ask.
If it's
Totally fine.
common knowledge.
So why do we use that
Yeah.
all the time for everything?
You guys, why do you just ask a great question? Why do we use Latin?
For everything.
Because scientists hate us, I guess.
Because it's,
No.
I don't know, what's it called? Universal.
Yeah, it's universal. So even with, within languages, they all have roots in there. Is it like Spanish would probably have bits and pieces in like Italian, and you guys, it's just a universal type of.
Everything
What
except
about that
Asian
language
languages
that's
nowadays.
Like a combination of 5 languages and is also supposed to be super easy to learn and is universally recognized.
I am unfamiliar.
German?
It's like it's not Spanglish. It's the one with like
Bangladeshi.
yeah, sure.
Okay, but you guys, so this is correct. This is how it needs to be. If you underline the whole thing, make sure there's a part in the words. You capitalize the genus. You lowercase the specific epithet or the species. If we were on a computer, what would we do instead?
Italicized.
Yes, we would do italics. That's how it's supposed to be. Okay.
Do you italicize the space in the middle?
All right. So now we're gonna take a break between the lecturing. I want you guys to go to Monday's training, and you're gonna pull out the paper that's in there.
I want to keep looking at dead scripts.
You guys are going to practice your own classification skills. Philip, you look stressed.
He's tired.
Let me see this real quick.
Oh wow, thank you.
Sorry, buddy.
Angel,
First question, you guys.
what is your step doing here?
Adrian, hush. You guys, that first paragraph is just helping you relate your own real life stuff to the science of it. Yes, it's talking about shoes. I have fruits over here. We may or may not have time to do that part. I'm gonna put it out here just in case you finish early. The point of this, you guys, is to show you that you can classify pretty much literally everything by looking for similarities and differences. This is the old way of classification. Later in the week, we're gonna talk about the modern way of classification. We're gonna talk about what convergent evolution is and how that might have messed with things. Because think of it like this, you guys, if you're looking for straight up similarities and differences, what would be the issue with classifying dolphins back then? Think about it. What do dolphins look like?
That's a
You just
weird
look at it.
Leathery.
No, okay, great, but where do they live?
The ocean there.
Ocean, okay, what do they have, Arizona? What's their body parts?
A blowhole.
Fins. What else has fins and lives in the water?
A shark.
Fish. There's a
Has a
strong likelihood that you would have classified a dolphin as a fish back then.
Blowhole.
Because how often did people back then go and catch themselves a dolphin like it was nothing? Yeah, see, if you're looking at it, you're gonna be like, that's a dolphin. You're gonna trip out on the blowhole a little bit,
Okay.
but you might just be like, okay, whales and dolphins are their own type of fish. You can't touch them and see that they're producing their own body heat. You're probably not gonna observe them like feeding their young and see the milk, so you're probably gonna assume they're fish. But as modern, techniques go on and you can check out the DNA, you're gonna be like, there is no relation to the fish. They are in fact mammals. So you're gonna go through this. You're gonna practice. You're not gonna be classifying shoes. That's just the weird first paragraph. You're going to classify, let's see, seaweed, rabbit, a green plant, mushroom, worm, and a grasshopper. I'm gonna see how you guys place them in your own categories. There's no right or wrong, okay? Just make sure it's logical. Make sure that you're backing it up with like, I put this in this category because of this and this similarity or this difference with this other thing. Phil, did you have a question?
Are we using their Latin?
No. You guys won't be using Latin names, just use the common names that it gives you right here. This is just a quick practice. Yes, Adrian?
How many categories are we allowed to organize them
However
in?
many you think is necessary.
Plant.
So it's totally up to you. If you think you need a bunch of categories, that's great. If you think you only need 2 or
Category
3.
for every single one.
No. You gotta make sure you find similarities and differences. Don't put them all on their own. That's cheating. Okay. So that's basically all you're doing. When you're done, if you magically somehow finish super quick, you may... Oh man, my fruit's already getting yucky. You can come up
Buddy
here
will eat it.
and write down on a piece of paper how you would classify these fruits. Notice, these are quite similar, yes? Yes. What is similar?
Yuck. Oh, one's delicious and one's an orange.
Apple from the orange
They have like
tree.
the same pattern.
Can I eat
Yeah,
the
yes.
lemon?
Okay, yeah. Buddy actually brought up a good point. One tastes yummy, one tastes...
Like an orange.
Okay, one tastes yummy, I'm assuming that's the orange.
One tastes like an orange.
And one tastes sour. You could use that as a way to classify. That is not a bad thing. Yes, look at them, but like, and please don't lick my fruit.
I'm sorry.
But technically, you could use taste as a way to classify.
Well, can I have the
Yes,
other
Adrian.
Are you gonna use this fruit anytime else in the day?
If you guys really want them by the end of the day,
I call dibs on the lemon.
I can Shh. Focus. I will cut them up for you. But right now, focus on your assignment at hand, okay?
The whole lemon.
Let's copy each other.
Hold on. Hey. Why don't you do it like
You
this?
can all
Let's get this right. So you have 2 main classifications. Plants and animals.
Yes.
That's great, that's fine. But I want you to break it down even further if you could. Think about it. Think about it. Who, out of these 3, who's more similar to who?
The grasshopper and the worm.
Right, okay, so why don't you, let's do like a branch.
What is that?
Connect those 2. And let's say, here, call them what you think they're called. If you had to loop those 2 together in a group.
Like their combined names.
What are they? Insects?
Yeah. Is worm an
Kind of.
insect?
Mm-mm. Now go ahead and group them together and just, non-mammals. Why don't you put that? What they are. And then that leaves the rabbit. And what is it? Good. See how you broke it down even further? And then why don't you do another branch?
Could I say this with like 2 like The mushrooms kind of like,
Are mushrooms plants?
are they?
Are
No.
they? No.
They aren't?
Fungi. It's okay. See, here, why don't you think about that though? Why is mushroom not a plant? What color are mushrooms?
They could be a lot of colors.
Are they evergreen?
No.
No. What are almost all plants?
Green.
No, there's no very obvious difference there. So fungi is its own whole mushroom. And then those two that are left are your plants.
I've got a quick question.
Yes?
Do they know fungi were different than plants in the separate groups?
Probably because the similarities and differences are very obvious. And you can look at it and see it.
One has spores.
Okay, so these are both plants, right?
Yeah.
What's the difference between seaweed and like just a green plant that's on the land?
Well, seaweed is underwater.
There you
It's
go.
a water plant.
So label it like that. Aquatic plant versus terrestrial plant. Plant. Words are hard. Okay, and then why don't you finish labeling these? Break those guys up. Insect, worm. Which is still an animal, but its own classification. Okay, Marilyn, how are we doing? Mm-hmm.
And fungi is its own classification, so mushroom goes there.
Good.
And the only animals I see are the rabbit and these two are
Good.
basically insects.
This one is an insect.
That
This one's
is,
still
I don't know the name of the
Platyphantes, I think. But it's okay. You don't need to worry about writing that. We'll just put insect, and then you can put worm as separate. But it's definitely not an insect.
yeah.
Okay. But you're doing good, and you're providing like logic for answers, right?
Yeah.
Cool. Great. Quentin, how are you doing? Good. Good. Don't forget to smile.
Did you read the third question? No, I'm curious.
Yes.
Do it again.
That's pretty good.
Like separating them by habitat.
Yes, that's fine. Yes, Arizona. Sorry.
What does it mean, like, organize it by categories?
So you can do this
Together?
Yeah, how would you group? So I don't know. The way my brain works is I just start grouping off the obvious, so like animals versus plants. And then you can branch it out from each other, like literally go you can do it in columns too. Plants. You have a fungi in here, right? Mushroom. Plants, fungi, animal, perfect. And then I would, from those, you can get messy as you want.
Sorry, I put my categories in a second and then we realize that what the third question was.
We'll finish it tomorrow.
Yeah. The second one is separating them. The third one is describing what your categories are. Like what makes it that category.
You like it? Cool, awesome. Okay, and then what I would do to make it. Yes.
The
And then I want you to
detronification?
branch,
No, I
so
don't.
what I would do is like mammal and then
I don't know.
and these, but just call it worm and then
Hey Phil, what was the
break those up.
scientific name for the worm, the detritophore?
Look how this is classified on the poster.
You identified it?
I'm asking, yeah, like what is it? Okay. Yeah, I don't know, sorry.
Hold on.
You may want to ask
Hold
us
on, hold
young.
on. Breathe,
Try to
breathe.
separate to the fungi. Fungi can go away. Fungi can become mushroom.
You can remember that.
But I don't think you need to worry about those specific names, like she's just like put them in the classification. You can use the common name, so you can just put worms.
Okay, was it
You don't
just
have to
you
write
that
down
idea?
the detritophore or whatever.
Okay, you guys. Tell me about amphibians. You just did this poster. You've got this. What do amphibians have but no one else has? Think of their skin. Easiest one. No.
Fish have scales.
No scales.
You're also thinking
Smooth
about
skin? Okay, well what happens when you touch a frog? What's it feel like?
It's weird.
Mucus. So we've got mucus and think of like, is it easy for stuff to travel through that skin? It's very, it starts with a P, very
Perceptive.
No. No. When it's easy to like go through something, it's permeable.